Thank you for the introduction, Stefan. So I'm going to discuss, give you everybody a quick overview and the various monitoring methods that we at Optron have at our disposal, I should say, for the mine, particularly in the mining sector. Before I go into that, it's quite important to understand exactly what you are monitoring and why we have monitoring in place. And traditionally, in a mining environment, monitoring is centered around an open pit. And primarily, we're looking for slope stability in that open pit. It's obviously safety critical, but also just to understand if the mine is behaving in accordance to the design. So typical failure modes in a pit can involve slumping, or that's where the bottom fails, wedge failure, which is typically on a bench. You can have a circular failure or toppling. So these are kind of the primary failure modes that most mines are looking into with a modern monitoring solution. But it's not limited to the pit only. The tailings dams are also considered very, very critical from a safety factor. And the failure modes that typically occur around a tailings could be heave or settlement, but there's also the slope failure of the tailing structure itself. It could slump or slide, or piping, which is occurred when there's some seepage that occurs through the dam. But again, although these are the two primary areas on a mining site that have active monitoring systems in place, it's not really limited to those areas. Monitoring can also take place outside of these areas where there may be fixed plant or production facilities. They could be quite close to a pit or be located on unstable ground. Crushers and conveyors are often installed or reinstalled in areas where there's been some reclamation and some compactions occurred. So there's ongoing movement in there. We all know that waste piles are prone to movement on mines, but due to their size and complexity, it's not always possible to understand exactly how that movement's going on. But there are some methods available for that, and just general areas around the pit. As I said, there's often earthworks that's going on in support of the main mining operations. So monitoring of these areas often become very useful and sometimes mandatory. So to give you a quick overview of the various monitoring sensors that are available, I'm going to be discussing the geospatial sensors, optical and GNSS side of things. I'll give you a brief introduction into geotechnical instrumentation. And later on in the second presentation, I'll go through the ground-based radar and satellite radar solutions that are available. So from the geospatial tool side, we are able to offer the Trimble total stations, S5, S7, and S9. The S9 is the flagship total station, ideally suited for a mining environment. It's very accurate and has long-range capabilities. And also the Trimble Denio 3 precise level. I often say that a precise level is an extremely effective monitoring tool, because you can deploy it quite rapidly. It's quite easy to train up personnel in using it, and you can get millimeter results quite quickly. So it's a very cost-effective solution. So it's a very useful monitoring tool. And on the GNSS receiver side of things, Trimble has the Netar9 TIM. It's a dual frequency receiver. Traditionally, utilizing a GNSS receiver for monitoring is not as accurate as a prism-based monitoring solution that you'd get from the total stations, but it's very useful in providing a level of redundancy and also for checking your control points. Often your total station position and the reference station, the reference prisms, are located quite close to the edge of the pit or within a zone of influence from the mining activity. And utilizing a GNSS receiver in tandem to the prism monitoring solution can give you an excellent overview on how your control points are behaving and whether they're stable or not. So moving on to geotechnical sensors, there's a vast array of geotechnical sensors available. And whilst the optical sensors and the GNSS sensors are focused above ground, the geotechnical sensors are located predominantly underground. They also, they're designed to measure very localized movements in localized areas. Vibrating wire piezometers, for instance, are designed to measure changes in water pressure at varying depths, and often soil saturation of water translates to movement above ground. So utilizing these tools, utilizing these sensors gives you a great idea of where movement may be coming from. Crack gauges and strain gauges provide excellent and very high degree of precision on linear displacements. Very good way of monitoring cracks for if they're opening or closing, or if there's some shearing going on, depending on the geometry of the installation. And then extensometers, tilt meters, and inclinometers, all very useful in-ground instrumentation to determine what's happening below ground. And apart from that, there's a myriad of other sensors out there. And if any of you guys have any particular requirements for geotechnical sensors and want to discuss it further, certainly something we can assist you with. Obviously, there's no point in having all of these sensors in place if there's no way of communicating with them. And this is where a wireless telemetry communication system comes in. This is a system developed by World Sensing, and the product is called Load Sensing. It enables any geotechnical sensor to be coupled to a wireless node. You can hook up to 5 sensors to a single node. They're very easy to set up, but what it does is it enables the sensor to communicate its readings wirelessly to a central gateway, thereby allowing you to automate the whole reading process. You don't have to send anyone out to site to take readings where there is, with the human error factor, then you may have misreadings or lack of readings due to inaccessibility. The beauty about this system is it allows up to 15 kilometers if you have line of sight. But even if you don't have line of sight, you can get 2 kilometers. It's been tested with 2 kilometers where they've been installed underneath manhole covers. At our demo site in Steenbras, which Cobus will come onto in a bit, we've got a piezometer used as a gauge to measure the dam level, and that's about 6 kilometers away, and we definitely do not have line of sight, and the system operates seamlessly. It's very low power. It comes with internal batteries that can last literally years, depending on the measurement frequency. But if the frequency is 2 hours plus, they can last in excess of 5 years. Very quick to install, and they literally you can connect practically any sensor, any common sensor on the market can be coupled to these data loggers. So how it works is you've got the sensor, which is your geotechnical sensor, wired in locally to a data logger. It's configured once on site or in the office prior to installation. It's configured to communicate with a single gateway using low frequency radio waves, which are certified to work in South Africa. So there's no licensing issues there. The gateway is linked directly into T4D, and our guest speaker, Christian, will describe T4D in a bit more detail, where any users can then interrogate the data, do analysis and reporting, alarming, etc. So to give a quick overview of our ground-based monitoring solution, regardless of where the monitoring is, whether it's on the pit or the tailings or any structures around site, all of that instrumentation, whether it's from the total station, GNSS, geotechnical sensors, or manual measurements from from the precise level, or even just booking crack measurements. They can all be integrated into a single platform, which is Trimble 4D Control. As I said, we'll be discussing this in a bit more detail. But from there, you have access to a myriad of tools allowing you to analyze and visualize the data, create alarms, automatic reports, etc. Having said that, this is not just a Trimble only platform. It's not ring-fenced around Trimble products only. Third-party sensors can also be integrated into it. And if you already have a Leica total station system on your site connected to GeoMOS, it is possible for the GeoMOS data to be automatically pulled into T4D. T4D does this automatically in the background and then allows you to utilize the advanced reporting features and alarming system and automatic reporting, etc. that's available on the T4D platform. And I think this is a good place for me to pass control back to Stefan and pass it on to our next presentation. Thank you.